Hello, everyone. Thanks for inviting me for the data-centric conference. So I will talk today about large image datasets. And my name is Danny Bigson, and I'm a CEO of a new startup called Visual Layer. So visual data, when I say visual data, I mean images and videos. They are exploding around us. There is a huge amount of information, starting from manufacturing, where I worked at Apple, social networks where users share video, and self-driving cars, which have tons of video data. And this data is just growing and expected to grow way more. Now, from my personal experience, I worked at Apple and I worked on manufacturing. So we had millions of images a day, and I had a 10-person team working on computer vision. And very quickly, we found out that 80% of our time were spent on data issues, and just a small chunk of our time was spent on algorithmic fun issues. And the reason is that data is coming in a lot of different formats. There are a lot of issues with the data, bad labels, corrupted images, things that are copied across S3 bucket locally, and so on. And overall, there is a lack of tooling for allowing us to interact easily and in a streamlined fashion with the visual data. Now, this is not just my personal experience. I spent a year after I left Apple for talking to companies that are doing computer vision in production. And I talked to more than 150 companies, interviewing them. And not surprisingly, most of the complaints are around the lack of tooling for visual data. No company complained about training speed. The training speed is too slow, but a lot of companies complained about fragmentations. They're not sure where's their data. Different teams are working with different formats. It's hard to share data. And overall, everything is a pain. I can give one example. Companies are working often with S3 buckets. They store their images, but since there is no preview, they need to copy images locally to understand what's there. And it's really hard to actually grasp what's going on. And we wrote all kinds of preview tools and thumbnails and indexing, but still it's something that's not supported out of the box. Now, those issues are not just annoying for computer vision teams. They are often problematic for companies because it slows down the time for creating successful computer vision projects. It compromises the model quality, and also it wastes a lot of the hard computer vision skills that are hard to hire, but still they waste their time on shuffling data around and writing tools and scripts again and again. So I would like to take a case study of some data set that is pretty famous that we looked into great detail, which is the ImageNet dataset. It's one of the most cited computer vision datasets with 32,000 citations. And what we looked is to see what's the quality of the data there and which thing we can find when we dive into what's going on inside. So we were pretty surprised to find out that there are a lot of different issues with this data set. So our first finding was that there are around 200,000 broken images. When I say broken images, I mean images that were downloaded from the web, but there was a missing product item in the store. And so we got some kind of error message. And no one before us identified this problem where those images appear with valid labels like a dog or a basketball, but still they completely confuse the model because they make no sense. Another thing that we find, which was surprising, is that the dataset, which contains 11.5 million images, has 1.2 million duplicates. And this is just waste of storage. So around 10% of the images are just duplicates. It slows down, it wastes your storage, it slows down the compute, and overall it doesn't contribute anything to the model. And when I say duplicates, I'm talking to images that are either exact similar or almost identical, a few pixel difference, but really look the same as in the examples I show here. Another problematic issue is that there are a lot of train test leaks. When we say train test leak, we mean that the test set should be clean and not contain images that the network was trained on. And since the network have seen those images, we don't want the network to memorize those images, and we want the test set to be a fresh test set. So this was also very surprising that the dataset was not methodically checked. By the way, for the train and test leaks, I'm referring to a cleaner subset of ImageNet, which was prepared by Alibaba, and there we found those issues. Another interesting thing is that we identify groups of images where they are the same image, but they have tons of different labels. Probably the image was duplicated many times, sent for human taggers, and each tagger wrote something completely different. And this is very problematic because you cannot train a model on all those images. In this example, we see all kinds of flavors of red wine, but it doesn't make sense. A model cannot understand the difference between red wine to desert wine to vin ordinaire because the images are completely the same. So there is no hope on classifying them based on the image. So overall, when we did this analysis, we saw that we needed to write specific tools that can scale to this data magnitude that we're talking about, tens of millions of images. And we decided to release our tool as a free tool, which is called FastDo, because we started to fast find duplicates, but then we added more functionality. And the tool is available in GitHub, and everyone is encouraged to try it out and experiment on your own data sets. So FastDo was designed to be super easy to use. It's a Python package. You just do pip install FastDo, so it's easy to get started. It's efficient in the sense that we can scale to tens of millions of images in a couple of hours. In this example, for the full ImageNet, it takes us around $1 EC2 cost, which is almost nothing. And it's accurate, which means that we can work and get good results on a variety of data sets, different types of verticals, and we are not tied to a specific vertical. And of course, the tool is free, and you can try it out on your own data. So we implemented some of the building blocks that are very common and essential when investigating a new data set, like outliers. In this example, this is a face recognition data set, IMDb. Everything was supposed to be here faces, but we see crazy images like shoes and ocean and radio and airplanes, which of course are not faces, and those are images that confuse the model and are problematic when we train. Other types of functionality we added are clustering, visualization, and search capabilities based on the image content. So we released the tool 3 months ago, and overall we see amazing adoption from the computer vision community. We got almost to 80,000 installations, and we start to see a lot of different contribution. For example, those are all kinds of cool Kaggle notebooks that we find in different areas where they show that FastDo tool is gaining a lot of insights on different types of data sets. And the last thing I want to show is a quick demo of FastDo. So I prepared it on a Collab environment, which is also available from our website. So this is pretty easy to start. You can just look at the Collab and run it. So the first thing you do, you just install FastDo, and then you import it. As I said, it's a quick installation. Here I prepared a data set, which is a food 101, 101,000 images. So those parts I will skip. They're already random because it takes a few minutes. And the next thing we can do is gain the insights from the data sets. And here I show it in real time. So the first thing we can do is look at different statistics of the data set. For example, here we see the darkest images. You can see the brightest images, images with with the largest number of colors and so on. So those are different types of slicing and dicing you can do on your data to see what's going on there. Another type of functionality that our users like is finding duplicates. So here I'm showing different images that were by mistake included a few times, and we can identify those images. Furthermore, we don't do only just duplicates. We can also find clusters of activity. So here we show that we can compute components of similar images. So this nice fancy cake is actually appears in different images. We can cluster it automatically and gain insight to the user. What are the images, not just one by cluster of activities. Another thing which is popular and useful is looking at outliers. So you can see all kinds of weird images. They are not food. We automatically find them without looking at the labels, and we can flag them and handle them. And you can see all the outliers we automatically find do not look like food. One last thing I show here is that we can also do different types of slicing and dicing. For example, we can bring outliers for the apple pie class. And here again, there are images, but for specific class, we can find outliers. The last thing I want to show is that we did also TensorBoard integration. It's another cool functionality. We also provide as part of the tool, you can save your data set in a TensorBoard format, and then you can play with different type of visualization. You can see the labels, you can click an image and see the most similar image, and you can slice and dice and dive more deeply into the internal of your data set. So that was my demo. And just to give a little credit for my team. So this is my team. My collaborators are Amir Alush and Professor Carlos Gestrin from Stanford. Thanks a lot.